Hey and welcome! Today we will solve longest palindromic substring interview question, which mostly asked by Google as well as other companies like that. So let's dive in. Here is first example. As you can see, we need to find a substring which is palindrome but the longest possible. So in this case, we have two options to choose from. First is BAB and second is ABA. But since they are both same lengths, we might return either of them. Second example, same story. The longest one is BB in the middle of this string. So we might return that. Just a quick disclaimer. First example has odd lengths and second one has even lengths. That is an important point and we need to consider that. Let's see how we are going to solve this. Basically, a brute force solution for this could be we can check every possible combination of words by using a double for loops and have a utility function in the other hand, which is only responsible to check if the passed word to it is palindrome or not. But as you might guess, by this solution, we are talking about O of n cubed time complexity. So there might be a better way. The idea is we can iterate through every character of given string and start looking to its left and right. If we see that they are not matching, we should proceed to the next character and repeat the process. And if we see a match, we expand or look up, and as soon as we find a mismatch of characters, we store it and proceed to the other character in the row. But as you can see here, we have two possible palindrome candidates in this example. At this step, what we need to do is compare the lengths of both findings, and if our new finding has more characters in it, replace the result variable. But in this case, both of them have equal lengths, so we don't mind replacing it. Then we will continue that cycle again until we reach into the end of string, and finally we can return what we found from iteration. But wait, this word has odd lengths, right? What will happen for even length words? Answer is simple. In that case, since we cannot have a middle character to compare left and right, we will consider character itself as left one and its neighbor as right. Then that should become easy to compare and expand or look up. Generally speaking, this solution that we use for even and odd length words is called expand from center, which has been applied for every character in the word, and it will bring us O of n squared time complexity instead of O of n cubed. So let's jump into the code to implement this solution. First, we will create our result variable. Then we will do a simple iteration over string. Now, before we jump into handle the cases for odd and even length words, let's create our helper function that does the expansion logic. We will call it expand from middle and pass it the string itself and left and right indices. We will do a while loop that checks for three things. First is left index is not goes far left below index 0. Second is right index is not exceeds the length of string. These two checks basically means we are in bound of our string. And finally, if characters at those indices are equal. If that is the case, then we might expand. And at the end, we will substring based on indices and return to our parent function to store the match we just found. But you may ask why +1 for the left index and not for the right index. Let me explain it. So when we are referring to an index, we mean exactly here. This is index 0, this is index 1, this is 2, and so on. And don't get me wrong here. In case of arrays, it's absolutely definite that we want the element in exact indices that we are referring to. But for strings, we always talk about the beginning points. This is the basis for, I could say, all of the string methods in JavaScript that deals with index of a character, like slice, splice, char-at, substring, and so on. Probably there are some unknown exceptions as always, but you know what I mean, right? This is how indices works for strings. So in case of our while loop, actually when we are doing a comparison based on left and right indices, the exact point that we decide that, okay, characters at these indices are not matching with each other, we have already decremented the left index and incremented the right index in the previous iteration. Now, if we break out of this loop, because of that falsy situation, this could cause us problem when we substringing. It will give us wrong indices, right? So for the right index, it's fine. We won't care about it because it's our ending point. And as I said, it always points to the beginning of the character. But for left index, it will refer to the wrong index, the decremented index, actually the one before what we need. So that is why we are adding a +1 to the left index before substringing or match. Now it's time to use this expansion logic and store the match. We will have two scenarios, odd and even cases. For odd cases, we will call our helper function, pass required arguments, and store the result in a variable. Just note that we are passing the same index as left and right for odd case. That literally means the first iteration for odd cases will compare the same character at the same index, but it will take the real effect when it expands after first time and starts to compare both neighbors from left and right, as we saw in the slides. Then we always going to compare the lengths of what we found with currently stored result that we may have already, just to make sure that we always replace if we found a longer match. And this is going to be the same for even case, but the only difference will be in where we pass the index in our helper function. And again, same check of lengths. Finally, we will return our result variable. Now, if I run this, test cases are passing, and if I submit, everything seems to be fine. Just a quick thing before time and space complexity analysis, and as an answer to your probable question of will we run our helper function for both even and odd cases, I might say yes, but the point is even strings will not mess with odd functions result, and the other way around. Odd strings will not mess with even functions result. And more importantly, since these helper functions are being called next to each other, it will not hurt or time complexity. Now let's jump back into the slides. For time complexity, we will have O of n in power of 2 as we discussed it through the slides, where n is the length of our string. For space complexity, it will be O of 1 because we just create a result variable. So that was it for this video. Thanks for watching, and please leave a like, comment, and subscribe to the channel. I will put the link for strings playlist in the description to check it out. And finally, hope you enjoyed this video and stay tuned for the next one.